Okay, so we're on to lesson 71 now, which is from page 176 of your textbook. So it's the third lesson in mechanics, and it's called Standard Units and Basic Dimensions. Okay, so first we start with a discussion of the standard units and basic dimensions. Let's have a look. I think you'll know a lot of these already from what you've done in your first term. But I'll read it through anyway, and then if I come across anything that I think's different, I'll stop and explain. So all quantities in mechanics are defined in terms of three fundamental quantities or dimensions: mass, length and time. Quantities or dimensions are measured in units. So some SI, that stands for Standard International, I believe now. I've just looked in the book. It says System International. System, so it's French. Yeah. Base units include the kilogram, the mass, kilogram for masses, metres for length, and seconds for time. Kinematics, that feels like that should be a heading, is the study of motion. So in kinematics we meet distance, displacement, speed, velocity, and time. And these are derived quantities that we can describe in terms of the fundamental quantities: mass, length, and time. Let's get this purple off because it's a bit silly. Right. So let's have a look at what we've got here. So displacement, the vector displacement has got a scalar distance. The fundamental quantity is the length, and the unit is the metre. Okay, velocity. So in a vector, that's when it's got a size, a magnitude, if you like, and a direction. Whereas the speed is just the magnitude, the scalar, sorry, is just the magnitude. So when we look about, we've got velocity, that's magnitude and direction. The speed, the magnitude is just the speed. The fundamental quantity is that it's metres per second. See, the units follow on. Length is metre, time is second. And in the last box here, this is how we say that. Acceleration, it hasn't got a corresponding scalar. Acceleration is the rate of change of velocity with time. So it's metres per second, or metres per second squared. Metres per second squared, metres per second, yeah. Sometimes I've seen it as metres per second, which sort of explains it quite nicely, I think, because it's how the metres per second, the velocity, is changing with time. Mechanics also involves the derived quantities force and weight. Okay, so the key point, force is mass times acceleration. So it's a combination of the mass and how you want to change the velocity. The SI unit is the Newton. Okay, weight is the force of gravity on an object. An object with mass m, I'm just reading this and I'm sorry, it's an object with mass m kilogram has weight mg newtons, where g is the acceleration due to gravity. On Earth, this is 9.81 metres per second squared, so three significant figures. If I was on the moon, our masses would be the same, but our weight would be less. And that's because the gravity on the moon is less. Correct formulae are dimensionally consistent. So this is what I was referring to up here. If you've got speed, which is length over time, is metres per second. And then velocity, acceleration, which is metres per second squared. If you think about it, it's metres per second, so it's metres per second squared. So it means you can check the dimensions to make sure you've got the right sums. Right, express a speed of 15 kilometres per hour in metres per second. So the way that I would do this, 15 kilometres per hour, that's going to be 15,000 metres per hour, and that's because 1 kilometre is 1,000 metres, which is 1,500 metres per 60 minutes. That's because 1 hour is 60 minutes. And this is 1,500 metres per 3,600 seconds. And that's because every minute is 60 seconds. So an hour is 60 times 60, 3,600 seconds. So this is put equals here. So on our calculator, if we do 15,000 divided by 3,600, it's 4.2 or 4 1/6. 4 1/6 metres per second. Okay, so they're exactly the same, it's just that the units are different. Right, for example 2, if U and V are velocities, A is acceleration and S is displacement, use the formula V squared equals U squared plus 2AS to work out S. If U is 24, V is 32 and A is 0.005. Give your answer in kilometres. Okay, so the first thing that I noticed when I was reading that out is this is kilometres per hour, this is kilometres per hour, and this is metres per second squared. Okay, now it says give your answer in kilometres, so I need to make sure everything is in kilometres, so I'm going to have to change this. I can either change these or I could change that, and I think I'll change this up to kilometres. So if it's 0.0, see what's happening there. 0.005 metres per second. Okay. Just thinking. So it's 0.0. I'm just wondering whether to change the other ones down to, and then change them back at the end. I'm going to do the ways just because the numbers, it's because of this, all these decimal places. If it's 0.005 metres per second squared, we can have lots of decimal places when we go to kilometres, because we haven't got much. So I'll go the other way. So 24 kilometres per hour is 24,000 kilometres metres per 3,600 seconds. That's from the, like what we've used in it as well. This way uses the example that we did before, so I don't have to do quite so much explaining. 24,000 divided by 3,600, which is 6 2/3 metres per second. Okay, that's the first one. That's U. V is 32 kilometres per hour, so it's 32,000 metres per 3,600 seconds. 3, 2, 1, 2, 3 divided by 3,620. 8.8 recurring, and I know that as 8 8/9 metres per second. Okay, and then I can use, and we've also got, then we're all in metres. That's the V that we can use. So if we've got V squared equals U squared plus 2AS, 8 8/9 squared, 6 2/3 squared, plus 2 times 0.005, that's the A, times S, which is what we want. S, not 5. Okay, so S is 8 8/9 squared minus 6 2/3 squared divided by, here 2 times 0.005 is 0.010. So divided by 0.01. That's rearranging, so I'll just explain what I've done there. I've taken that off that side, and then I've divided both sides by that. Take that away from each side. Divide both sides by that. So calculator now. So I've got 8 8/9 on my calculator left over from before, so I'm going to press squared. Minus 6 2/3. And that needs to be squared as well. 6 2/3 squared. And then divide by 0.01. So I've got S is 3,456.79 metres. 345,679. That's an interesting answer. I wonder if they knew that was going to happen. Just coincidence. Who knows? And we want the answer in kilometres. Well, 1,000 metres is 1 kilometre. So it's 3.45679 kilometres. Yeah, it would have been good if that 9 had been an 8. Never mind. Anyway, that's beside the point. Right, there we go. And that's some basic